So we are beginning with problem solving session on fluid mechanics, and this is the first problem number 1.317 in this series. So it is stating a pitot tube is mounted along the axis of a gas pipeline whose cross sectional area is equal to S. Assuming the viscosity to be negligible, find the volume of the gas flowing across the section of the pipe per unit time if the difference in the liquid column is equal to delta H and the density of the liquid and the gases are rho naught and rho respectively. So if we consider this problem from this diagrammatic aspect, then we are saying that the gas is flowing through this pipeline, passes this point 1, then hits the pitot tube over here at point 2. The first thing that we say is as the gas comes in contact with the pitot tube at point 2, it will come to a momentarily halt, that is V2 equals 0. The gas is having density rho and the liquid is having density rho naught. Over here it is also evident from this point that pressure at point 2 is greater than pressure at point 1, and hence it is pressing the manometric fluid in the downward direction. So over here we can write P2 minus P1 equals rho naught GH. So this is the first equation that we have written over here, which is the reading which we take from the manometer tube. Now if we apply Bernoulli's equation between the point 1 and 2, then we say applying Bernoulli's equation, so we can say P1 plus rho G H1 plus half rho V1 square equals P2 plus rho G H2 plus half rho V2 square. So over here the next line that we write over here is P1 being P1. Now H1 and H2. So if I consider this one as reference level, so I can say H1 and H2 both are equal to 0. That is, both the points 1 and 2 are on this same horizontal line. So hence we can say that this value equals 0, half rho V square, where V is velocity of flow, P2 plus 0 as the gas in pitot tube comes to momentarily halt. So the next that we write is half rho V square is equal to P2 minus P1. So over here we consider that the flow is taking place such that the density of the liquid and the gas are rho naught and rho respectively. So gas is having density rho and liquid is having density rho naught. So we are putting P2 minus P1 equals rho naught GH from equation 1. And hence from here we can say that velocity of flow V equals 2 rho naught G delta H by rho. So this is the expression for velocity that we have, 2 rho naught delta H by rho. So now the question is asking us to calculate the rate of flow of fluid or the volume of gas flowing across the section of the pipe per unit time. So volume flow rate Q can be written as cross section into velocity, and hence we say that Q is equal to S times of root over 2 rho naught G delta H by rho. So this is the final answer for this particular problem which we have discussed, problem 1.317.